In 1942, the Atlantic was Hitler's killing floor. His U-boats were winning the war. But the Allies had a secret weapon based on a prototype the Germans knew about and completely ignored. Many of us remember the stories of the terrifying U-boat Wolfpacks. They nearly starved Britain into submission. How did the Allies stop an enemy they couldn't even see? The answer wasn't a bigger ship, but a sound. Hitler's greatest strategic mistake wasn't invading Russia. It was ignoring a small group of scientists working on electronics. That single error cost Doenitz his entire U-boat fleet, and it's why ASDIC Sonar changed the world. In 1942, the Atlantic Ocean wasn't a highway, it was a graveyard. For Great Britain, it was the only lifeline. Every piece of fuel for their Spitfires, every tank for their army, every round of ammunition, and much of the very food they ate had to cross that dark, cold water. And waiting in that water was perhaps the most effective killing machine of the entire war, the German U-boat. This was a war within a war, the Battle of the Atlantic, and for the first 3 years, the Allies were losing it catastrophically. The man behind this campaign of terror was Admiral Doenitz. He wasn't just a sailor, he was a brilliant, ruthless strategist. He understood the U-boat's true power was not in sinking warships, but in strangling a nation by sinking its merchant fleet. He invented a tactic that haunted the dreams of every Allied sailor, the Rudeltaktik, or Wolfpack. The concept was chillingly simple. A single U-boat scouting a patrol line would spot a convoy, but it wouldn't attack, not yet. Instead, it would radio the convoy's position to Doenitz's headquarters in France. From there, the call would go out. Like wolves gathering on a scent, U-boats from hundreds of miles around would converge on that single point. They would shadow the convoy, waiting for nightfall. And then they would strike. Not one at a time, but as a coordinated pack, launching torpedoes from all directions, slipping between the escort ships, turning the convoy into a chaos of fire, explosions, and sinking steel. The happy time, as the U-boat crews called it, saw merchant ships sunk faster than the Allies could possibly build them. Britain was hemorrhaging. Prime Minister Winston Churchill would later write that the only thing that truly frightened him during the war was the U-boat peril. Because if that lifeline was cut, the war was over. Britain would starve, and America would have no way to enter the fight in Europe. The core of the problem was invisibility. A submarine, once it slipped beneath the waves, was gone. It was a ghost. The destroyers and corvettes guarding the convoys were sailing blind, dropping depth charges based on guesses or on the brief, terrible glimpse of a periscope. They were trying to hunt an enemy they could not see. It was a losing proposition. But the Allies had a secret. It was a piece of technology born in the final days of the First World War that promised to give eyes to the blind. It was called ASDIC. The name itself was a smokescreen, standing for the Anti-Submarine Detection Investigation Committee. It wasn't a very exciting name, and the technology itself in those early days was crude. Yet it held the entire hope of the Allied war effort. ASDIC was in essence a way to use sound to find things underwater. We know it today as sonar. It worked, in theory, just like an echo. A ship would send out a focused pulse of sound, a ping, from a device under its hull. This ping would travel through the water. If it hit nothing, it was lost. But if it hit the hard steel hull of a submerged U-boat, a faint echo would bounce back. The operator, wearing headphones, would hear that faint ping, ping, pong, and the machine would tell him the direction and the distance. For the first time, a hunter-killer ship could find a submarine that was hiding hundreds of feet down. It was revolutionary. And yet, the U-boats continued their slaughter. Because the Germans, and Hitler himself, knew all about ASDIC. And they weren't impressed. This is the central failure that would, in time, cost them the war. The Nazi high command, and Hitler in particular, was obsessed with the massive, the visible, the brutal. They poured their resources into giant battleships, like the Bismarck and the Tirpitz. They were fascinated by the Wunderwaffen, the wonder weapons, jet fighters, V-1 flying bombs, and the V-2 rocket. These were weapons of spectacle, designed to awe and terrify. Beside these, electronics seemed trivial. This quiet, fussy science of echoes and radio waves felt defensive, weak. The German Navy, the Kriegsmarine, had its own sonar called S-Gerät. But they saw it as a defensive tool, something to protect a harbor. They never imagined it could be turned into a decisive offensive weapon. Karl Doenitz, despite his brilliance, shared this blind spot. He had built his entire strategy, his entire career, on the belief that the U-boat's stealth was absolute. He believed that even if a ship had ASDIC, a skilled U-boat commander could evade it. He believed that the courage and training of his men would always triumph over a machine in a box.
This was their fatal underestimation. The Allies, on the other hand, had no choice. They didn't have the luxury of giant battleships to rule the waves. They were the defenders. They had to make electronics work. So while Germany was building rockets, Britain and America were building better circuits. They weren't asking, is ASDIC perfect? They were asking, how do we make it perfect? This difference in philosophy, arrogance versus adaptation, was the hinge upon which the entire Battle of the Atlantic would turn. And it's why, when the final prototypes were ready, the U-boat fleet was sailed directly into a buzzsaw. We talk about these pivotal moments, these hidden technologies, quite often on this channel. It's a passion of ours. If you find this kind of deep dive history valuable, taking a moment to click that subscribe button is a great help. It tells us we're on the right track and ensures you won't miss the next part of the story. To truly understand the German mistake, we have to look at what they were seeing. The early ASDIC of 1939 and 1940 was flawed, deeply flawed. It wasn't the magic bullet the Allies had hoped for, and it gave Doenitz every reason to be confident. First, the ping itself was a double-edged sword. When a destroyer sent out that pulse of sound, it was announcing its presence to every submarine in the area. The U-boat captain would hear the ping long before the echo came back to the ship. It was like a hunter shouting, "I'm looking for you," into the forest. A smart commander wouldn't wait to be found. He would dive deep and slip away. Second, the system was slow. Sound travels through water at about 4,800 feet per second. That sounds fast, but in combat, it's an eternity. The ping had to travel all the way to the target, and the echo had to travel all the way back. Over a distance of a mile, that round trip could take several seconds. In that time, a moving U-boat was no longer where the echo said it was. The hunt became a constant, frustrating game of catch-up. And third, and this was the most critical flaw, ASDIC had a massive blind spot. Imagine the ASDIC beam as the cone of light from a flashlight. It pointed forward and down, but it couldn't point straight down. As the destroyer raced in for the kill, following the pongs that were getting closer and closer, it would reach a point about 100 yards from the U-boat. At this range, the submarine slipped under the sonar cone. The pongs would stop. The operator would report, "Target lost." This was the moment of greatest danger. The destroyer captain was now blind. He had to guess where the U-boat was. He had to sail over the spot where he thought it was and roll his depth charges off the back. But a good U-boat commander, the moment he heard the destroyer's propellers overhead, would order a hard turn and a crash dive. More often than not, the depth charges would explode harmlessly, hundreds of yards away, while the U-boat slipped away into the dark. And finally, the ocean itself was a traitor. The ASDIC beam was just a sound wave, and sound waves are affected by the medium they travel through. The ocean is not one uniform body of water. It's full of thermal layers, patches of cold water and warmer water. When the ASDIC ping hit one of these layers, it would bend, just like light through a prism. It would give false readings or create shadow zones where a U-boat could hide, completely invisible. So, Doenitz looked at this technology and saw a clumsy, flawed tool. He instructed his captains on how to exploit its weaknesses, and they did so with lethal skill. Hitler, seeing the tonnage charts still climbing, saw no reason to divert his resources from his prized V-rockets. He underestimated electronics. But the Allies, led by the British, knew these flaws were not a dead end. They were an engineering problem. They didn't scrap the system, they began to build around it. They set out to create a system of technologies, prototypes, that would work together to plug the holes in ASDIC. The first piece of this new puzzle had nothing to do with sound. It had to do with radio. The Wolfpacks, to be effective, had to communicate. The scouting sub had to radio Doenitz. Doenitz had to radio the pack. These were short, high-frequency radio bursts. The Allies developed a technology called high-frequency direction finding, or Huff-Duff.
It was a brilliant piece of electronic detective work. A ship equipped with a Huff-Duff antenna could catch one of these short U-boat transmissions. It couldn't tell what they were saying. That was a job for the code breakers at Bletchley Park. But it could tell the direction the signal came from. Now imagine a convoy with two escort ships miles apart. The U-boat sends its signal. The first escort gets a bearing, signal from the northwest. The second escort gets a bearing, signal from the northeast. Where those two lines cross on a map, that's the U-boat. Suddenly, the hunters had a general area. They could dispatch a fast destroyer or corvette to go investigate. The U-boat, thinking it was a hidden scout, had just given away its own position. This was the first nail in the Wolfpack's coffin. But this only worked when the U-boats were talking. What about when they were silent, or when they traveled on the surface? This is where the second piece of the electronic puzzle came in: airborne radar. U-boats of that era were not true submarines. They were submersibles. They were diesel-electric boats. They could run on batteries underwater, but those batteries had to be recharged. And to recharge them, they had to run their big, air-breathing diesel engines. That meant they had to surface, usually at night. On the surface, they felt safe. A lookout in the dark could spot a ship's silhouette long before the ship could spot the low-lying U-boat. But they couldn't see an airplane. The Allies began equipping long-range aircraft, like the B-24 Liberator, with new air-to-surface vessel, or ASV radar. These planes could patrol the Atlantic hundreds of miles from land. Their radar could pick up the tiny blip of a surfaced U-boat from miles away through total darkness or thick fog. This led to one of the most ingenious inventions of the war, the lee light. A U-boat commander surfacing at 2 a.m. would feel secure. Suddenly, out of the night, a B-24 Liberator would be roaring overhead. An enormous, blindingly bright spotlight, the lee light, would flick on, turning the U-boat's conning tower into day. The U-boat crew, blinded and stunned, had seconds to react before the plane's depth charges were falling around them. It was terrifying, it was devastating, and it was all thanks to electronics. Of course, the Germans were not stupid. Doenitz and his engineers reacted. They realized they were being hunted by radar. So they developed a countermeasure, a radar warning receiver called METOX. It was a crude-looking device, a wooden cross with wires on it that the crew would mount on the conning tower, but it worked. It could hear the pulses from the Allied ASV radar long before the radar could get a solid return. The U-boat captain would hear the dit-dit-dit in his headphones, cry alarm, and the boat would crash dive to safety before the plane even arrived. For a time, the hunters were blind again. It became a high-stakes, lethal game of electronic cat and mouse. The Allies had to respond, and their response was a war winner. Their scientists, working in secret, had developed a completely new type of radar. The old radar operated on a long 1.5-meter wavelength, which the Metox receiver was designed to catch. The new prototype operated on a tiny 10-centimeter wavelength. The German Metox sets couldn't detect this high frequency at all. The U-boat commanders listening intently heard only silence. They believed they were safe. And then, out of the silent night, the lee light would flash on and the bombs would fall. The U-boat crews were completely baffled. They began to believe the Allies had invented a way to smell them. Their morale began to crack. This combination of Huff-Duff and 10-centimeter radar meant the Allies could now find the U-boats, day or night, on the surface or when they transmitted. But there was one problem left to solve, that blind spot underwater, the ASDIC flaw.
Even when a destroyer found a sub and forced it down, the kill was still not guaranteed. The captain still had to make that blind gas in the final 100 yards. The Allies needed a weapon that could kill the U-boat while the destroyer still had a solid ASDIC lock. The solution was another prototype, a strange and brilliant weapon called the Hedgehog. It wasn't a depth charge, it was a forward-throwing mortar. Picture a set of 24 small, rocket-like bombs arranged on a launcher at the bow of the ship. Now picture the battle. The destroyer is closing in. The ASDIC operator is calling out the range. Target at 500 yards, 400 yards, 300 yards. The U-boat commander is preparing to make his hard turn, knowing the destroyer will soon be blind. But before the blind spot at 250 yards, the destroyer captain gives the order, fire Hedgehog. With a whoosh, 24 small projectiles arc up into the air and fly ahead of the ship, landing in a wide circle on top of the U-boat's position. The U-boat commander hears 24 small splashes, and then silence. This was the psychological genius of the Hedgehog. Unlike depth charges, which were set to explode at a certain depth, the Hedgehog bombs only exploded on contact. If the bombs missed, the U-boat crew heard nothing but the splashes. But if one bomb hit, the U-boat was finished. The tension in that submarine waiting in the dark to see if one of those 24 splashes meant death was unbearable. Now all the pieces were on the table. ASDIC to find the sub underwater, Huff-Duff to find it when it talked, radar to find it on the surface, and Hedgehog to kill it without ever losing contact. Hitler and Doenitz had focused on building a better spear. The Allies, by necessity, had built a perfect shield, and now they were adding a spear of their own. A huge part of this new aggressive stance was the American contribution. When the United States entered the war, they brought their full industrial might to the fight. We've all heard of the Liberty ships built in weeks that helped to simply outproduce the U-boat sinking rate. But just as important was a new type of warship, the escort carrier. These were known as jeep carriers, or CVEs. They were small, slow, and unglamorous, often built on the hulls of merchant ships. But they were one of the most important weapons of the war, because these ships could carry a dozen aircraft. This solved the final problem of the Battle of the Atlantic, the Black Pit. This was the area in the mid-Atlantic, too far from America, too far from Britain for land-based aircraft to provide cover. This was where the Wolfpacks reigned supreme. But now, the Allies could put an airfield in the middle of the convoy. These escort carriers, combined with long-range destroyers, formed new hunter-killer groups. Their job wasn't just to defend the merchant ships, their job was to hunt. When a Huff-Duff signal was picked up, a hunter-killer group would peel away from the convoy and attack the U-boat, chasing it for hours, sometimes for days, with airplanes and ships working in perfect coordination. The hunter had become the hunted. And then there was the greatest secret of all, the one that tied everything together. At Bletchley Park, a quiet country estate in England, the Allied codebreakers, including the genius Alan Turing, were fighting a silent war of the mind. They were trying to break the Enigma machine. For long stretches of the war, they succeeded. They could read Karl Domanitz's most secret orders to his Wolfpacks. This was the ultimate trump card. The Allies didn't have to fight the Wolfpacks. They could simply read their mail, find out where they were going to be, and route the convoys around them. It was a brilliant war-winning combination of intelligence and electronics. But the Germans were not idle. In early 1943, Doenitz sensed something was wrong.
He suspected his codes were broken. He ordered a massive upgrade to the U-boat Enigma machine, introducing a new, far more complex four-rotor version called Triton.
For the code breakers at Bletchley Park, the lights went out. The U-boat traffic went silent. They were blind. This single change led directly to the deadliest period of the entire battle. With Bletchley Park blind, and with Doenitz now possessing the largest U-boat fleet of the war, over 200 operational boats, he launched an all-out assault. He believed this was the final, decisive blow. The winter of 1942 and early 1943 was a time of almost unimaginable slaughter. The Wolfpacks were back, and they were winning. In March of 1943, the battle reached its terrifying peak. Two massive convoys, HX-229 and SC-122, sailing close together, were intercepted by a Wolfpack of over 40 U-boats. The battle that followed was a running three-day nightmare. The escorts were overwhelmed. They fought bravely, but they were too few. 22 merchant ships were sent to the bottom. Over 140,000 tons of supplies were lost. In return, only one U-boat was sunk. It was the single most disastrous convoy battle of the war for the Allies. Karl Doenitz was triumphant. He was promoted to Grand Admiral, Commander-in-Chief of the entire German Navy. He told Hitler that victory was at hand. Their belief in the U-boat and their dismissal of Allied electronics seemed to be vindicated. This is the kind of turning point we often get requests to cover. Many of you in the comments have asked for more stories about these technological turning points where the war balanced on a knife edge. We do read every one of those comments, and they genuinely help us decide what stories to tell next. So if there's a battle or a prototype you want to see, please let us know. But Doenitz's victory in March was a false dawn, because in April, two things happened simultaneously that would seal his fate. First, at Bletchley Park, after months of frantic, desperate work, the codebreakers broke the new four-rotor Enigma. Suddenly, the lights came back on. The Allies could once again read Doenitz's orders. Second, the new prototype systems were finally ready. The escort carriers, the B-24s with their 10-centimeter radar, the destroyers with Hedgehog, the corvettes with improved ASDIC, they were all now arriving in the Atlantic in huge numbers. The trap was set. Doenitz, arrogant from his victory in March and still blind to the electronic revolution that had happened under his nose, ordered his Wolfpacks to sea in May 1943 for the final kill. What happened next is known to history as Black May. It began with convoy ONS-5. Doenitz concentrated a massive force of U-boats to intercept it, and they found it. The attack began, but this time something was different. When the U-boats attacked, the escorts attacked back with a ferocity and coordination the Germans had never seen. When a U-boat radioed a contact report, a hunter-killer group, guided by Huff-Duff, immediately raced down the bearing and forced it under. When the U-boat surfaced at night to attack, they were found, not by sight, but by the invisible beam of 10-centimeter radar. Allied planes and ships, materializing out of the darkness, sank them before they could even fire a torpedo. And when the U-boats dived, the destroyers no longer sailed blindly overhead. They locked on with their improved ASDIC. Their Hedgehog mortars fired, and the U-boat commanders heard those 24 terrible splashes. The battle for ONS-5 was a slaughter, but not for the convoy. The Allies lost 12 ships, but in return, the U-boats were decimated. In that 1 month, May 1943, Karl Doenitz lost 41 U-boats. 41! These weren't new crews on training runs. These were his aces, his veteran commanders, the men who had taught him the business. They were irreplaceable. The losses were so staggering, so sudden, that the entire U-boat arm was gripped by panic. On May 24, 1943, Karl Doenitz, the man who had come so close to winning the war, wrote in his war diary. His words are chilling.
We have lost the Battle of the Atlantic. The enemy has succeeded in gaining the upper hand. The enemy's new locating devices, their electronics, have rendered the U-boat ineffective. He finally saw the truth. Hitler's underestimation of electronics, an underestimation Doenitz himself had shared, had proven fatal. The war was not won by the biggest battleship or the fastest rocket. It was won by the quiet men in laboratories, by the women in the radio rooms listening for faint signals, and by the cold, precise pulse of electronic prototypes. Doenitz had no choice. He pulled his U-boats out of the North Atlantic. The lifeline to Britain was open. This victory, won by sonar, radar, and code-breaking, was the linchpin for the rest of the war. Without it, the massive buildup of American men and material in England for the D-Day landings would have been impossible. The invasion of Normandy and the liberation of Europe began not on the beaches of France, but in the cold, dark waters of the Atlantic, with a ping. The war at sea did not end, of course. The Germans, in their desperation, proved they too could innovate. They introduced the schnorkel, a breathing tube that allowed U-boats to run their diesel engines while submerged, making them true submarines. They also introduced a deadly new weapon, the Gnat, or German Naval Acoustic Torpedo. This was a terrifying device. It was a torpedo with a microphone in its nose. It was designed to listen for the high-pitched sound of a destroyer's fast-turning propellers. The U-boat didn't even have to aim. It just fired the Gnat in the direction of the escorts, and the torpedo would home in on the loudest sound it could find. For a time, it was devastating. Allied escorts were suddenly the prey. But the electronic war had one more round to play. The Allies, in response, developed Foxer. This was simply a noisemaker, a set of metal bars towed hundreds of yards behind the destroyer. It was designed to make a louder, more attractive noise than the ship's own propellers. The Gnat torpedoes would hear this decoy, swerve away from the ship, and harmlessly attack the Foxer.
Once again, electronics had beaten electronics. The war of echoes and pulses continued until the very last day. When we look back, the story of ASDIC and the Wolfpacks is more than just a history lesson. It's a profound lesson in strategy and arrogance. Hitler and his high command were blinded by their own vision of warfare. They believed in the mystique of the U-boat ace, in the power of brute force. They could not see, or would not see, that the future of war was being decided in university laboratories. The simple, hard truth is that the Battle of the Atlantic was the world's first true electronic war. It was won not by the side with the most steel, but by the side with the most advanced circuits. That humble prototype, the flawed and clumsy ASDIC of 1939, evolved. It became the sophisticated sonar that every navy, and indeed every commercial fishing boat, relies on to this day. Every time you see a fish finder on a base boat, you are looking at the direct descendant of the technology that saved Britain. The underestimation of electronics was a mistake the Third Reich could not recover from. It allowed the Allies to build their bridge of ships across the Atlantic, and over that bridge marched the armies of liberation. This story is number 29 in our series on the pivotal moments of military history. If you found this account as fascinating as we do, I highly recommend our previous video on the Battle of Midway, which was another battle decided by intelligence and timing. You can find that in the playlist that should be appearing on your screen. We know this was a very detailed story, but the key takeaway is simple. The war was ultimately won by the side that respected and nurtured innovation, no matter how small it seemed. If you like our efforts in this video, let us know in the comments section. Thank you for your time and for joining us in remembering this critical, hidden chapter of history.